Annurag Srivastava, and today I am going to speak on the changes made in the latest AIAG VDA FMEA Handbook. This tutorial will help you to understand what is FMEA, the history of FMEA, what was the need for the FMEA to get revised, and more importantly, the changes done in the latest FMEA revision. I will present this tutorial in a very easy and simple way for you to understand the matter clearly. So let's start. First, we shall understand what is FMEA. Basically, FMEA is an acronym which stands for Failure Mode and Effects Analysis, and it is an analytical methodology used to ensure that potential problems have been considered and adhered throughout the product and process development. It is developed by a cross-functional team. The size of the team depends on the complexity of the design and the size of the organization of the company. FMEA development is also meant to be before the event and not an after the fact exercise. And this upfront review and completion of FMEA protects you from any crisis situation later on. FMEA is a living document, and the FMEA should regularly be reviewed, and it should reflect all the latest changes and action. The other important point to consider here is that FMEA is also not a standalone document, as output of FMEA can be used as an input for subsequent product development process. So FMEA is considered as a tool to identify potential problems and take actions for the potential problems, as a tool for risk evaluation, and the management carries the responsibility for the application of FMEA. Ultimately, management is responsible for acceptance of the risk and the risk mitigation actions identified. It is also acting as a tool for reliability improvement, as it helps you to identify the severity of potential effects of failure and to provide an input to mitigating measures to reduce risk and estimating the probability of occurrence of the cause of failure and the failure mode. So to minimize risk, the likelihood of failure occurrence is to be reduced, which increases the product or process reliability. We have understood what is a FMEA. Now let's go through how FMEA evolved over the years. The history of the development of FMEA goes back over 60 years. In the year 1949, FMEA was first developed by US military as a military specification called as MILP 1629, and in 1963 it was used by NASA for Apollo project. In the year 1977 marked the beginning of the use of FMEA in the automotive industry by Ford Motor Company. In the year 1980, German Association VDA developed FMEA for the industries in Germany, and in the year 1986, VDA Volume 4 was released. In the year 1993, first AIAG FMEA reference manual was released. In the year 2015, the need was recognized to harmonize the AIAG and VDA FMEA manuals. Now then, what created the need to revise the FMEA manual? It was done to benefit the multinational OEMs and suppliers by harmonizing both the AIAG and VDA FMEA manual. The suppliers supplying their products to both the European and American OEMs were required to assess their products' failure mode and failure effects differently based on the difference between the severity, occurrence, and detection rating tables in AIAG and VDA FMEA manual. This caused confusion and added complexity to the product development and product improvement activities of the suppliers. To address this issue, both the manuals were reviewed and they made their way for the new VDA FMEA handbook that has shared requirements and expectations with regard to FMEA and enable the supplier to follow a standardized process of FMEA that meets the requirement of both European and North American OEMs and produce more robust, acceptable and complete FMEA. The first edition of AIAG VDA FMEA Handbook was released on June 2019 with a common set of FMEA requirements. As per AIAG VDA FMEA, it defines FMEA as a systematic, qualitative, analytical method which is intended to evaluate the potential risk, analyze the cause and effect of failures, and document preventive and detection action and recommended action to reduce risk. Now, what are the linkages between IATF 16949 and FMEA? Doing a robust FMEA is also a direct requirement of the Quality Management System Standard IATF 16949. The clauses 8.3.2.1 for design and development planning, other clause 8.3.5.1 design and development output, and third clause 8.3.5.2 manufacturing process design output has a direct reference for the application of this methodology. Now comes the most important part of this learning session, that what are the major changes in this new revision. The first is the methodology of formulating FMEA and results communication. The second is severity, occurrence and detection rating, which are redefined. The third is new action priority tables are now available. Fourth is the link between cost of quality and FMEA. And the fifth is the supplemental FMEA MSR concept. Now let's understand each of these changes in detail. As per the new guideline, the FMEA is carried out in 7 steps. These 7 steps provide a systematic approach to perform FMEA and serve as a record of the technical risk analysis. The first step is scope definition and project planning. Its purpose is to describe what product or process are to be included and excluded for a review. This allows you to review all processes at a high level and determine which processes will be analyzed. The second part is structural analysis. Its purpose is to identify and break down the manufacturing system into 3 elements: process item, process steps, and process work element. Process item means what is the end results of all the successfully completed process steps. Process steps means the manufacturing operation under consideration. And process work elements, in this you identify potential causes with respect to men, machine, material, method, measurement, and work environment that could impact the process step. The third step is function analysis. It describes what the process item or step is intended to do. There may be more than one function for each process item or step. This step is also broken down into similar 3 steps as done in structure analysis. The first being function of focus element, the second is the function of process step, and the third is function of work element. The fourth step in the process is failure analysis. It helps to identify failure causes, modes, and effects, and show their relationship to enable risk assessment. In the new revision, there is a change in the order of column in the PFMEA form to make failure chain following the sequence of failure effect, failure mode, and failure cause. The fifth step in the process is risk analysis. In this, you assign prevention controls and detection controls and ratings for severity, occurrence, and detection for each failure chain. The sixth step in the process is optimization. Its purpose is to determine the actions to mitigate the risk and assess the effectiveness of those actions, and reassessment of the actions. In this revision, the change is done in the recommended action column. Now it is split into 2 columns for capturing preventive action and detection action. The 7th and the last step in the process is documentation and communication. It summarizes the scope and result of an FMEA, for communication within or between companies. The first three steps, scope definition and project planning, structure analysis, and function analysis, are related to system analysis. And the last three steps, failure analysis, risk analysis, and optimization, are part of failure analysis and risk mitigation. The last step, documentation and communication, is part of risk communication. In this change, the severity, occurrence, and detection rating tables have been redefined completely. Severity, which talks about the severity of the failure effect, is having 10-point scale with new definition for each level. Safety is 10 regardless of warning, and 9 is for regulatory, which was not the case in earlier AIAG FMEA revision. Occurrence talks about the occurrence of the cause, and it is also having a 10-point scale with a new definition for each level. In this revision, there is added emphasis on prevention control as input to occurrence rating. Detection stands for detection of the occurred failure cause or failure mode. In this new revision, it considers capability to detect and the timing of it in allocating the rating. Another major change in the new revision is the use of new action priority tables. The previous FMEA manual suggested the use of risk priority number, that is RPN, but it failed to provide the logic to select the RPN for prioritizing the action considering the several combination of severity, occurrence, and detection. Let's understand this with an example. In scenario A, we have severity as 8, occurrence as 5, and detection as 2, which gives us an RPN of 80. In scenario B, we have severity as 5, occurrence as 2, and detection as 8, which also gives us an RPN of 80. If you see, both have the same RPN, but difference is in severity. So if you go by RPN, you will get misleaded to choose which scenario needs to be prioritized. The action priority table provides this logic to the FMEA team to prioritize the actions as per the scenario, as per the combination of severity, occurrence, and detection by the reference of action priority table and categorizing into high, medium, and low priority. The action priority strongly favors error proofing. Action priority is considered high or medium for severity and occurrence with moderate ranks, even when detection controls are effective. Implementing error proofing solution is the faster path to downgrade action priority levels from high to medium and medium to low. Now, what is the link between cost of quality and FMEA? When used correctly, a major benefit of the FMEA is being able to mitigate the risk while balancing cost, leading to organizational stability and growth. To achieve this, you should be able to connect the FMEA to the cost of quality. Traditionally, there are 4 categories within the cost of quality, 2 of which fall under cost of poor quality. External failure costs are the results of failure that exist outside the organization, such as failing to meet a requirement, which is also categorized under cost of poor quality. Example for this can be warranty costs, customer returns, sorting, etc. The internal failure cost is the result of failure that exists inside the organization, and this is also categorized under cost of poor quality. Example, scrap cost, rework cost, overtime of machine due to high scrap, etc. Appraisal costs are associated with the testing and monitoring of items or activities. Example, routine testing cost, labor cost, etc. And the prevention costs are associated with any activity that prevent failure. For example, auditing, training, and FMEA development process is a part of prevention cost. The FMEA development process is a deep dive analysis for the potential for both internal and external failures. So the FMEA directly affects an organization's success in keeping its cost of poor quality low. by allowing an organization to take on time right preventive actions. So if the external and internal failure cost is greater than the preventing activity failure cost, then it indicates the FMEA is ineffective in providing the value you expect. By monitoring the cost of quality, you can understand the effectiveness and efficiency of your FMEA. Hence, during the new product and process development, the current cost of quality will be the baseline. And if the team decides to improve the cost of quality, then more robust current prevention and detection controls have to be developed. Another major change in the new revision is the use of supplemental FMEA MSR. MSR stands for Monitoring and System Response. This was not previously addressed in AIAG FMEA 4th edition. In this, the potential failures under customer operating conditions are analyzed. The analysis can be part of DFMEA, in which aspects of development are supplemented by aspects of customer operation. One of the main thing here, it is supplement to DFMEA for maintaining a functional safety. The functional safety concept defines the requirement to ensure the safety goals that needs to be met by design. So FMEA MSR may be used to supplement DFMEA by analyzing the effectiveness of diagnostic monitoring and system response in maintaining functional safety. Another changes in FMEA MSR, the detection rating scale is replaced by monitoring rating scale. With all these changes coming in, one question comes to my mind is, what will be the impact on the existing FMEAs? What we need to do for our current FMEAs? The answer to this is very clearly defined in the AIAG VDA FMEA Handbook, that the existing FMEAs may remain in their original form. The team may decide to transfer the data to the latest form in order to take advantage of improvement associated with the latest FMEA procedure. For new programs, FMEAs should be converted to comply with the new format. However, if the team determines that the new program is considering a minor change to the existing product, they might decide to leave the FMEA in the existing format itself. With this, I have come to the end of this knowledge sharing session. Please do like and subscribe my YouTube channel so you can get latest updates of my upcoming videos. Hope you have enjoyed and liked this video. See you soon with more interesting videos. Till then, keep learning, keep sharing. Cheers.